right, hey everyone. Today I'm here with Ryan Lebois from Space Exploration Engineering, also known as C, kind of for short. And C is one of our sponsors for the upcoming Space Software Summit. So I want to let you go ahead and introduce yourself, Ryan, and tell us about yourself and a little bit about the company.
Sure. Thanks for having me, Ryan. Glad to be here talking about this and also to be attending the summit coming up. Um, like Ryan said, I'm from Space Exploration Engineering, SEE. I'm the manager of our mission integration for AstroFDS, which is our flight dynamics system product. Um, that's one of the things that we do at SEE, but I'll give you a little bit more of an overview of the company before we dive into AstroFDS specifically, which I think brings us to the summit. SEE is a small company. There's about 16 or 17 engineers. We're spaced around the country from coast to coast. We all work distributedly and asynchronously sometimes, but we support missions ranging from LEO all the way to deep space, and many of us have worked together for 15 to 20 years on the missions that we support. We work everything flight dynamics, so navigation, trajectory design, mission design, operations, and of course ground software development as well. Out of the missions that we've worked, we have probably the highest concentration of experience in cislunar space. I think we're probably up to something like 60 missions or so that we've supported, maybe a few more, and I think 15 or more of those are cislunar missions. So it's an area of expertise for SEE, and something that we've grown together over the years, and one of the reasons that this team particularly is together. Um,
That's awesome. I didn't even know there were 15 missions. I mean, obviously over a large period of time, but that's a lot more than I thought were going on. Can you talk about any of the specifics of any of those missions?
sure. So the one that brought a lot of our team together was the Laddie mission, which was out of NASA Ames. So that was a lunar orbiter, and I think at least 6 or 7 of us worked on that mission, and it was where where we met a few of our now coworkers. But that was one. The others, we've worked a lot with some lunar resonant missions. So IBEX is one that we worked on that launched back in 2008. The TESS mission, which went out of NASA Goddard, that was another one that we worked on. Both of those are in these resonant orbits with the moon. And we've worked on a few others. John Carrico worked on L-Cross. We helped Rocket Lab with the Lunar Photon mission that launched the Capstone spacecraft. And we've also supported some other international customers besides New Zealand. We've supported KARI in South Korea during their KPLO mission, along with many others. But both commercially and government, and U.S. and internationally, we've kind of supported a whole range of those missions.
That's amazing. So you definitely say that cislunar is one of the unique aspects of your software. Is there anything else that kind of makes it really unique?
Um, yeah, I would say the software itself. So that's our mission experience with trajectory design and mission design. For our ground software, one of the unique things is that it does support those types of missions. A lot of ground software that we see is geared towards LEO, where we see GPS navigation and certain sorts of automation and capabilities that aren't necessarily applicable to cislunar and above geo or even deep space missions. So one of our key features is that we do support the whole range of missions from those LEO constellations all the way through deep space missions that need more rigorous navigation support. I'd say the other thing well, I'll kind of come back to that question because once we get into AstroFDS, I think there's a few things that I'd like to highlight.
All right. Well,
Um,
let's get into AstroFDS. Tell me all about it, and love to know how it works and what you guys can do.
Sure, yeah. So AstroFDS, like I mentioned, it's our flight dynamics system product. As long as we've been operating spacecraft, we've also been building software to do the flight dynamics ground processing. And that's evolved over time. And with all of these missions that we've supported, we tend to leverage that experience to improve our products and to build in the features that we as operators need to be able to fly those missions. Um, some of those things that have come about in AstroFDS as a modern version of the flight dynamics system. It's a cloud-based application. It's got a web UI. We primarily deploy to AWS, but we've also deployed to GCP and to local hardware. It's very flexible based on our customer needs and security levels and whatever they need to be able to support their missions. The web UI then interacts with our backend microservices, so orbit determination, trajectory design, products generation, all of the flight dynamics functionality that you would expect. Um, and those are all containerized applications that we orchestrate through Kubernetes. And that allows us to scale the processing on the back end to support customers in LEO that have large constellations that need to be able to fly 50, 100, 1,000 satellites, as well as scale down for the single satellite missions, which are a lot of the historical missions that we've supported over time. Um,
So you said your software can handle a whole constellation, like a single installation of the Astro FDS can handle even up to 1,000 satellites?
it can, yeah. So AstroFDS wrappers around the ANSYS products, Systems Toolkit, SDK, and Orbit Determination Toolkit, ODTK, as the astrodynamics engines. And we run those mostly in their headless versions, which are ODTK runtime and SDK engine, because those can be run in containers that can be scaled easily to support parallel processing for large constellations like that. AstroFDS also has an automation and scheduling service built in, so we can take customizable processing sequences, which might be something like read in incoming tracking data or telemetry, run an orbit determination, update some maneuver plans, and generate products. And we can take that sequence and automate it to run on a cadence and also to kick off for all satellites in a constellation and scale up to the limits of our licensing capability with the ANSYS products underneath. So all of that generates a lot of data. We use Grafana as a very, usable interface for data display and something that a lot of the industry is familiar with. That sits on top of our Postgres database and allows us to display all of the data coming from either a single satellite or a constellation in a way that's customizable and operators know how to use pretty well.
So Grafana would be used for like a lot of detailed graphing and things. Do you have any orbit visualization or any 3D type stuff like that?
We don't, not built directly into our UI. We do have the ability for AstroFDS to interact with the Windows UI versions of SDK and ODTK. So an operator that has access to a license on their local machine can open up 3D visualizations and see that while things are executing and while the processes are running. We have talked about building a cesium interface into the AstroFDS UI, and it is something that probably down the road we will get around to. But for the most part, for the missions that we're supporting, those Grafana displays are going to provide the real information that operators need to make decisions and do their job.
Yeah, what I found in most cases is the 3D visualizations are eye candy, but they're not actually very useful.
Yeah.
So I see that it's cool to hear that that's a similar viewpoint that you guys are taking. Um, let's talk about the conference. So what are you guys excited about for the Space Software Summit?
I'm really excited because I don't really attend many software-focused conferences. I think that's very valuable because anyone who's operated in a mission operations center knows that there's a lot of different pieces of software that come together to fly a spacecraft. And even for a mission to be successful, all of those pieces have to come together and operate seamlessly. And that includes, I'm going to always put flight dynamics right at the center because in my world that's where it lies. But there's command and control, there's mission scheduling, there's the ground networks, and the flight software on board, and it all has to be able to interact together. And I think a lot of times those components are all brought together at the mission level, where we've all won some awards or contract to support a common customer, and the team is assembled, and everyone has to define their ICDs and work together to get everything functioning. But I think there's also a lot of opportunity for partnering ahead of time and going after the larger sections of the ground system, for instance, when they're proposed. And a lot of commercial operators we find would rather buy sort of in a single system sort of approach rather than piece together a ground system from 5 different providers. Whereas government customers, we've seen both instances where they sometimes are willing to go out and get their favorites in different locations. But a conference like this really gives us a chance to explore some of those partnerships and integrations, and figure out, going forward, who can we contact, who can we work with to set up some integration demos, and take our software together to tackle some of these customer RFPs and proposals that are coming out. And I think also just looking at the agenda, the discussion of technology topics is a big one. By getting together and talking about what are the effects of AI and improved high compute on board, on the overall industry, it lets us adjust our roadmaps in sync so that we can kind of take our products and incorporate some of those new technology trends together.
Yeah, I mean I think that's a great summary of why I wanted to have this conference in the first place, is to kind of get all these different pieces together in one place. And there's existing ground software conferences, there's existing flight software conferences, but there's not been a like just all aerospace, especially space particular software all together in one place. A chance for people doing innovative stuff, AI stuff, the best in class of all these different groups too. You mentioned that people are often looking for a complete solution. But a lot of people also want options, right? The government's big on not having lock-in and not having a single vendor solution. So having different people from different groups like you guys and be able to see best in class for each of the different applications, I think is going to be a great opportunity at the conference to kind of discover what's out there and hopefully take some things home from you that you can use on your missions going forward.
Yeah, I think that's very valuable, and it certainly will be for SEE. Like you mentioned, between having separate conferences usually for ground and flight software, I think that's a really interesting place where this conference is hoping to, I think, bring some of both of those together because, like I mentioned earlier, one of the trends I see a lot of is the desire, at least, for more onboard compute, more onboard autonomy, and
Hmm.
things that might have traditionally been on the ground are starting to move on board. And by having legacy ground system and software developers interacting directly with flight software developers, I mean, you're going to get some of the lessons learned of why these things are hard on the ground and translate those to flight software and potentially unlock some really awesome capability in the next decade.
Yeah, I think the lines are definitely blurring between what has been traditionally ground versus what's in flight, simply because the flight is becoming more and more, has more reflows. They're running Linux. Some programs are actually running containers in
Hmm.
space at this point, right? And if you're running a container, you can run pretty much anything in flight. You're still probably power constrained. You've still got some differences. There's definitely a place where the ground is going to be able to, scale up 100 servers for AWS to handle, like you said, a constellation worth of planning. But it's going to be interesting to see how the lines change between what's done on the ground, what's done in space, and as well as the communication architectures as well. Things like Starlink, where we can theoretically have continuous contact. We don't have to worry about is it over my antenna right now because we've got interconnects.
Hmm.
So the dynamics are gonna change a lot in the next 10 years, and you can already see it with AI. The AI coding stuff is already amazing. Um, Lots is going to be changing in the industry, and I'm trying to capture as much as that possible for this conference to bring that all together.
That's great. Yeah.
All right. Well, thanks for talking with that. I hope everyone's getting excited about the conference from this discussion. Um, Looking forward to seeing everyone there. Is there anything last comments you'd like to add before we wrap this up?
No, really looking forward to it. I'm from the East Coast, so I always take every opportunity to come to Colorado, and yeah, looking forward to sharing some time with other software vendors and developers.
Awesome. Yeah, it's going to be great. October's a great time to be in Boulder. It's going to be awesome. Leaves will be just starting to change in the mountains, and looking forward to seeing everybody there. Great. Thanks.
Great. Thanks, Ryan.